Hello. This video is our first video on logic, and the learning goals are that by the end you should be able to identify what a statement is, and if you have enough context you should be able to evaluate whether that statement is true or false. You should also be able to use truth tables to evaluate compound statements involving and, or negation. So in other words, you should be able to take two statements and put them together with an and or an or using a truth table. And you should also be able to negate a statement with the help of a truth table. So what is a statement? A statement is a sentence that is either true or false. So let's see some examples. Here are some examples. The first few I've written in set notation. So they might not look like sentences to you, but remember when you see something like this, what it means, it translates into, so I'm gonna put this arrow here to say, this is equivalent to saying that 7 is an element of the natural numbers. Natural numbers. So that's a sentence, and it happens to be true, so it's a statement. So this is true. What is this next statement mean? How does this next statement read in words? Well, it says really that the empty set is an element of the real numbers. Now, the empty set is a subset of the real numbers because you can always take the set of real numbers where you just don't take any numbers, right? And that's the empty set, but it's not an element of the real numbers. So this is another statement, and this statement is false. What about this? The next thing is a sentence. Add 5 to 7. Right? It's a command, though. It's not a statement that can be true or false. You're telling someone to do something. So this is not a statement. And here's another sentence. All flowers are purple. This one is a statement. It's either true or false. And you can see over here, I have some sunflowers in that corner of the room. They're orange, right? They're not purple. So this is a statement, and this statement is false because I can see, looking over in that corner of my room, that not all flowers are purple. I found some that aren't. Okay, so that's what a statement is. It's a sentence that can be either true or false. Our text makes a distinction between statements and things called open sentences that depend on variables. I'm not going to be so concerned about you learning the difference between statements and open sentences. We'll never use that language in our class. And honestly, I don't think it's that important. It's not something that I think in either computer science or mathematics people really talk about. And what I want for this course is to do things with you that are going to feel important later on. And this one isn't, trust me. Okay, so what is important though, is that we learn to combine these statements in logical ways and understand the meanings of those combinations. So let's talk about how we might combine statements using and or. So sometimes what we do, if we have a sentence, it's often makes things a little simpler if we represent that sentence by a letter, just for ease of notation. So suppose, going back to this example, I'm going to let this sentence be P. So P is the sentence, is the statement, 7 is a natural number, and Q is the statement, the empty set is an element of the real numbers. And let's have, that's enough for now. Okay, so that's P and Q. So definition. So if P and Q are statements, the new statement P and Q, which we can denote in logical notation like this with this caret, is true when both P and Q are true. We can make a little truth table to summarize this information. And here's what we would do. The truth table would have one column for P, one column for Q, and one column for the new statement P and Q. So then what I want to do on the left is have all combinations, all possibilities for the truth or falseness of the two statements P and Q individually. So it could be that P is true and Q is true, P is true and Q is false, P is false and Q is true, or P is false and Q is false. Okay, and so of those four different possibilities for the combinations of P and Q together, what we see is that the definition of P and Q being true, that only happens when both P and Q are true. And so in all other situations, P and Q is false. So for example, if we go back to those concrete examples and P is the 7 is a natural number and Q is the empty set is an element of the real numbers. So we could make a new statement that's 7 is an element of the natural numbers and the empty set is an element of the real numbers. So that's a new statement. It's either true or false, but it's a compound statement. So another way of writing that is it's the statement P and Q, and this statement is false because we are in this row of the truth table where the P statement is true, but the Q statement is false. Okay? So let's look at another way of making compound statements. So here's another definition. So if P and Q are statements, then P or Q is comma denoted P, and here it's like I turn that wedge upside down and make a little V, denoted P true when, and here let me summarize it with the truth table right away. Okay, so here I'm going to have a column for P, a column for Q, and a column for P or Q. And I'm going to write the truth table, and then let's see if we can work out the words that go along with this that describe what I'm saying in the truth table. Okay, so let's go through all the different combination of truth and falseness for the two statements. So it could be both true, P true, Q false, P false, Q true, or both false. And here is when the statement P or Q is true, okay? It's true in this case, this case, this case, but not this one, okay? So P and Q are statements, then P or Q is when either P or Q is true. And the thing to remember is that in logic, the statement P or Q is true when P is true and Q is false, when Q is true and P is false, and when they're both true, okay? So this is sometimes called an inclusive OR, and in our class, we'll always be talking about inclusive ORs. In normal English language, often when people say OR, they're kind of thinking of exclusive ORs, right? So like if someone invites you to a wedding and says, well, you can have chicken or fish, you're sort of supposed to either choose chicken or fish, but not both, okay? So it's a little different in our class. The or means one, the other, or both, okay? So for example, the statement 7 is an element of the natural numbers, or the empty set is an element of the real numbers, which I can think of as P or Q, like this, is true because we are in, just as we were before, this row of the truth table. But for the or truth table, that row is true. Okay, so that wasn't true last time when we were in that second row of the truth table. It evaluated to false because we're thinking of P and Q both had to be true. Okay, and then the last thing that I want to just mention in this video is the idea of negation. So if we have a statement then if we have a statement P, maybe, if we have a statement P, then its negation is denoted with this funny little, I don't know, that little character there. Not, we say not P. So this is read not P. So for example, if P is the statement 7 is an element of the natural numbers, then not P is the statement 7 is not an element of the natural numbers, okay? So this one is true and this one is false. So you'll have some examples in the pre-class questions. Well, you're going to be asked to translate between logical notation and words back and forth, statements back and forth, and also combining statements with and, or not. Okay, thank you very much.